It's Jacob Penrod 578 in class section. So today I'm going to be going through my code for homework 1. So most of my changes are in this SGD function, and I'll be going through the methods I added. So I as per the requirements, I added MSE, cross entropy, lag likelihood, and did some updates on the accuracy and correct count. So the big changes are these were implemented in the evaluate section. So in the evaluate, I did two big changes. So first, I set up this column function that's a little helper for me to make it easy. So I get all my labels I know are in column 1, and all my outputs are derived from column 0. So that's what this is doing. This is deriving my outputs by feeding column 0 into feed forward using the map and lambda functions in Python. So, and all I need for most of my methods is the length of test data. So using that, I just call all my methods to get with the actual answers, the actual answers, the expected answers, and the counts. So it's nice and clean. If we go here, so these functions are really quite simple. They just pretty much come off straight out of the book. So it's the average of the sum of the differences squared, and then cross entropy is just the log times the actual. So these are all vectors, so I'm just doing the MP sum, so it'll do it across all the vector entries. Seeds. And that is cross entropy, so the negative average of the sum of the actual answers times the log of the output and plus 1 minus the actual output, or the labels times log of 1 minus the actual answers. And log likelihood's even simpler. It's just the negative log of the actual answers divided, and that's the average of that. So I've got those implemented. They're straight from the book, and I even put the thing in comments. So I call these and evaluate, and then in back propagation we did a memory management update, and for that I build my matrix of activations before I assign them, so that way we're not appending during time, we're just overriding. And to do that, I also added an I counter on the biases and weights loop. So that's the changes I did in the code. So then I have this IPython notebook where I'm doing my experiments. The big thing I did here that's kind of different than probably everyone else did is I added a loop to go through several ranges. So I would manually test, figure out which ranges made sense, and then just try and loop through. I could never get 100%, but I got close. I got some that were 94 out of 95 and hit 100% on test, but not on training. And then I also implemented a basic chart showing my metrics, and so I could visualize what was going on with the models that I liked. And since there's a lot of random weights, this wasn't always the greatest, but it did give them a nice visual feature. Alright, that's homework 1.